Okay, we're going to continue with our review of Chapter 5, Jeopardy problems. We're going to do exponential functions. Compute the derivatives, y equals e raised to the sine squared x. This uses the chain rule. If you need to see this written in another way, it might help. Just let me go back to the page. This is e raised to the sine of x squared. So that might help. That means y prime. We know that the derivative of e to the u is just e to the u. So if I'm doing the derivative of e raised to the sine squared x, it's just going to be itself, e raised to the sine squared x. Times the derivative. So the derivative is 2 sine of x times the derivative of the inside, which is cosine of x. So it's kind of confusing to use the chain rule twice. So the derivative of this power was 2 out front, it goes to the front. Sine of x is left on the inside, raised to the first power, and then you have to use the chain rule again to say times the derivative of sine of x, which goes to the x. And I would just leave it like that. Not much you can do to simplify. Okay, f prime of x, part b, is going to be e raised to the e to the x, so the same thing, but then we always multiply by the derivative of that power. So the derivative of e to the x is just e to the x. Okay, that's it. Okay, next page. So I have find dy over dx if cosine of x minus y equals x times e dx. So this is an implicit differentiation problem. So the derivative of cosine is negative sine, so it's negative sine x minus y. Times we have to do the derivative of the inside, so the derivative of the x minus y. That's 1 minus derivative of y is dy over dx. Now you could have written dx over dx for the derivative of x, but that's just the same as 1. Okay, equals, so this means the product rule, so I have x times e to the x. So first times derivative of second plus derivative of first times the second. Okay, so I'm solving the dy over dx, which is a lot of simplifying here. So I'm going to do, you can pull out an e to the x for this part. So it's x plus 1 times e to the x. Not really going to help us a lot, but there's x plus 1 times e to the x. I'm going to divide by my negative sign of x minus y. And I have 1 minus dy over dx. That's what's left. So I need to I could subtract my 1 over. And now I need to divide by this negative. So I get dy over dx equals, I'm going to have negative of the first term. So basically all that does is get rid of that negative on the bottom. So I have x plus 1 e to the x all over positive sign of x minus y. And then I have plus 1. So when I divide by negative there, it's plus 1. And that's it. All right, find the 1,000th derivative of x, f of x equals x e to the negative x. So f prime of x, first times derivative of second, so e to the negative x times negative 1, plus derivative of first is 1, times e to the negative x, keep it normal. So I'm guessing there's some kind of pattern. So we're going to pull out an e to the negative x. When I do that, I have negative x plus 1 left. And we'll find our second pattern. That's first, e to the negative x, times derivative of the second, so derivative of the negative x plus 1 is negative 1, plus derivative of first, so e to the negative x times the negative 1, times the second one, negative x plus 1. So if I pull out an e to the negative x, I get negative 1 Then I have plus x, so negative x times negative 1 is positive x, and then negative 1 times positive 1 is negative 1. So it becomes e to the negative x times negative 2 plus x. Triple prime. I'm kind of seeing the pattern. Let's see if it works out. So first times derivative second, so negative 2 plus x. Its derivative would just be 1 plus derivative of the first, so e to the negative x times negative 1 times the second one. Okay, so let's see what happens. I have 1, so e to the negative x, I'll pull that out, and I have 1 plus 2 minus x. This is exactly what I thought. So hopefully you guys see the pattern too. So e to the negative x times 3 minus x. Okay, so let's see the pattern. So for the first derivative, I had a negative x, and the third derivative, I had a negative x. But the second derivative was a positive x. So I'm thinking anytime it's odd, it's going to be a negative x. Anytime it's even, it's going to be a positive x. All right, and then the other pattern is that the number of the derivative is empty. So f prime, so first derivative, I had plus 1. F double prime, I had minus 2. F triple prime, I had positive 3. So I'm going to have 1, 2, 3 are in there, and then it also has the sign going on. So I'm guessing that the 1,000th derivative, we're going to exist f first to 1,000 of x. Once you get past 3 primes, that's how you start writing it, is e to the negative x times it is even. So I'm going to have negative the number, so negative 1,000 plus a positive x, or you could write x minus 1,000. So it's e to the negative x times x minus 1,000. Okay, next one, find the equation of the tangent line to the curve 2e to the xy equals x plus y at the point 0, 2. Okay, again, we have to find the derivative implicitly. So I'm going to have the derivative of 2e to the xy is 2, e to the xy, the same thing, but times the derivative of xy. So derivative of xy is x times dy over dx. Or you can write y prime if you're feeling lazy. Plus derivative first is 1 times y equals derivative of the other side. So derivative of x is 1, derivative of y is 2y over dx. Okay, I like these ones because I'm supposed to find the slope at the point 0, 2. So you just plug in now. So I have 2e to the 0 times 2, 0 times dy over dx, plus 1 times 2 equals 1 plus dy over dx. So 2 times e to the 0, which is 1, so 2. This is knocked out at 0, plus 2, times 2, equals 1 plus dy over dx. That's 4. Subtract the 1 over, I get 3 equals dy over dx. Well, what is dy over dx? The slope at that point, so that's your end value. And this is nice because it's at the point 0, 2. That means your y-intercept is 2. So that's your b value. So I have m and I have b. So my equation of my line is y equals 3x plus 2. Oops. Okay, the next one I have exponential functions, find the integrals. Okay, you can do a u substitution on this. A lot of people don't need to, they can kind of see what's going to happen in their head. So if u is equal to 2x, du is 2 dx, or 1/2 du is equal to dx. So when I replace, I'm going to have u now, so u of 0, so u of 3, of e to the u du. So that 1/2 is out front. So it's 1/2 e to the u, going from u of 0. So if you plug back into u equals 2x, u of 0 is 2 times 0, so 0. U of 3 is 2 times 3, which is 6. So I'm going from 0 to 6. So it's 1 half e to the 6 minus e to the 0, which is 1 half e to the 6 minus 1. So you might see it written like that, or e to the 6 minus 1 all over 2, which is minus 1. Or you could see the decimal version. So e to the 6 minus 1 divided by 2. Okay, that's about 201.214. So you can see that in the first one. Okay, the next one is also a u substitution. This one's a lot more obvious though. So I'm going to let u equal to 2 minus x squared, actually. It's not just 2 minus x. So then du is 2 times 2 minus x times the negative 1. The chain rule, dx. Well, we just want to replace this 2 minus x dx part. So let's divide by this negative 2 on both sides. So I get negative 1 half du equals 2 minus x dx. So what I have is 3 to the u. That's what I wanted. Du with a negative 1 half out half. So if I integrate 3 to the u, if you remember if I take the derivative of 3 to the u, remember that formula? That means not too bad. It's 3 to the u times the natural log of 3. Well, going backwards, if I'm integrating 3 to the u, it's 3 to the u divided by natural log of 3. It gets rid of that natural log of 3. Okay, so that's what we need. So I need 3 to the u, and then divided by natural log of 3. And I have that negative 1 half. Negative 1 half, so what's left? Okay, so it's negative 3 to the u, which is 2 minus x squared. Squared minus u. Yeah, that's what right, divided by 2 natural log of 3. So I can leave it like that. Or if it was a multiple choice question, just remember that that can also be pulled up with a power. So if you have natural log of 9 on the bottom, that's the same thing. All right, and this last one, I have 3 raised to the sine of x of cosine of x dx. This is another u substitution. U is the sine of x. Du derivative sine is cosine of x dx. That's what we wanted. That's our du part. So it's the integral of 3 to the u du, which we just said was 3 to the u over natural log of 3. Oh, I forgot my plus c on this last one, didn't I? Let's get your plus c. The plus c, which is 3 to the sine of x, that was u, divided by natural log of 3, plus c. Let's see how much time we have here. Okay, let's stop there. I'm going to go ahead and do the next problem on another video.